So today we will start our discussion using arrays on arrays, and then as we discuss arrays, we also look at for loop. So let's look at. So now, see, for loop is what is called as it's a control structure. It's a control statement, and so this is section 2 of Essential C contains discussion on for loop. Let's go to page 11. Yeah. So this is the syntax of the for loop. You can see the syntax of the for loop. You can, this is the general syntax, but just look at this this syntax that you are seeing here. This for I is equal to 0. So there are three parts. This is the syntax, no? For followed by parenthesis. Within parenthesis, there are three parts. The first part is called as an initialization part. And the second part is the continuation. And the third part is action. But what these are, we will see through an example. Okay. So let's try to write a small program which computes the sum of first n numbers. We want to write a program. So our goal is so to compute sum of n numbers. Okay, what is our problem? So we want to do this. Sigma I is equal to 1 to n I. So this is what we want to do. And the way we are going to write this program is so there is this variable called sum. There is this, thing, there's a beaker in which we store the contents of the variable sum. And there is this another beaker. So what happens is the contents of this beaker, it keeps going from, initially it will be 1. And then we pour in this 1 into this sum. And then after that, we change the contents of this beaker to 2. Okay, so and then we add the contents of this of 2 to this sum, and then we add 1 to 2 and we get 3. So what we keep doing is we keep incrementing the contents of this beaker, and then we keep accumulating it in the sum. Okay. So this particular idea of accumulation is what we will see now. So we use this variable in sum. So which we want to use sum to accumulate, to do the addition. And then, so we have this for loop. Now we write this for loop. So for I is equal to 0, I less than or equal to capital N plus I, or let me use I is equal to I plus 1. Sum is not a keyword, and so I use one more variable I. Printf. And then there is some logic that is present here. So finally, this is what we want. Sum of first %d Are you all with me? Forget about this loop for the time being. On line number 7, what is missing? We need to read the input, right? Scanf %d. Are you all with me on line number 7 and 8? On line number 7 and 8, we are reading the input. And we want to, after we have to write some code. Okay, good. I'm getting some interesting debugging ideas. Okay, scanf, printf. Okay, and then finally we want to print sum of first natural numbers is %d. That is our code. Line number 16, you're also good, right? Printf statement. It makes sense. Line number 16 is good. Line number 7 and 8 are good. And now we are writing a for loop. It starts from for 1 is equal to I less than or equal to n. And so we write sum is equal to sum plus I. So this is the code. And so here what is happening is, let me draw the flow chart for you for the flow statement. So what happens is, before there is some code before the for statement, but the equivalent of for statement in terms of flow chart is so the statement I is equal to 1 that is present here gets executed. Okay, this is statement 1. That is, and then after that, what we have here, this is the second part. This is the conditional. This condition will be checked. What is the condition? Whether I is less than or equal to n. This is checked. This is the second part. And there are two possibilities here. One possibility, this is, so if this is true, yes, then what happens is sum is equal to sum plus I. This is the statement that gets executed. And after this gets executed, control wants to go back to the beginning of the for loop here. The control wants to go back here. But before it goes back, it wants to execute the third part that is present here. That is I is equal to I plus 1. That is the third part. So as long as this condition is true, you keep going through this loop. So that is why it is called as a for loop. And on the contrary, if it is false, okay, if the condition is false, you come out of the loop, and after the loop, what do you have? The printf statement. The printf statement gets executed. Okay, let's say this is statement 4. 4 is here. This is statement 5. 5 is here. Are you all with me on this example? Do you understand this example? This whole flow? That's all for loop is. We can put I is equal to I plus 1 at the end of the loop. There are a few possibilities, but just understand this basic thing. So here what is happening is, when you enter the loop, what is the initial value of the variable sum? 0. And after it gets executed on line number 12, what will be its value? It will be 1. And when we come back again, so if you do GDB, and what will be the value of I is equal to 2, and we put accumulate 2 into the variable sum. So don't worry about plus plus I and I plus plus. Understand this logic. That is, it's a minor thing. So let's try to compile this program, and GCC. What is this program? CD CP21B. Yeah, GCC sum n.c dot a dot out we keep forgetting to put slash n here. Great. So this is a, see, both whatever you can do. See, Aneka has this question, why do we need this if you already have the while loop? My question is, why do we need this if you already have the go to statement? It's easy to write. It is easy. It's not the time complexity here. In this case, the time complexity will be the same whether you use go to or for. So depending upon, so it's not the speed. It is what is the right construct you use in order to solve a problem. So now, so GCC minus G, let's use sum n dot C. We are doing a GDB. Why the value of n didn't become? No, because remember the loop, remember the for statement. There is a semantics to this statement, to this for loop. As per the semantics, I is equal to I plus 1 gets executed after all the statements within the for loop are executed. Just because I is equal to I plus 1 is there on line number 10, it doesn't mean that it's what it is. You remember the flowchart that I have drawn? That is the meaning of this for statement. Are you with me? That the meaning of this for statement is the loop that we have drawn, is the flowchart that we have drawn. That is the semantics that is given. Yes, Gaurav. Yeah. Now, if you do GDB a dot out and TUI enable and run, so let's say I enter the value 3. Oh, it already ran. So let me put a break on line number 10 and run. So now we are on line number 10. What is the value of 5? It is not actually initialized already. It's not yet initialized. So because of it, it is still not 1. We didn't yet enter for loop. Okay, but what is the value of sum? Value of sum is equal to 0. What is the value of n? 3. So now when I say next, no? So now what is the value of I? Value of I is now 1. And what is the value of sum? Remember, we still didn't execute line number 12. So it is still 0. Now we are saying next. When I say next, now the value of sum becomes 1 because we added 1 to sum. So now we are on line number 10. So now what happens is, so print I. So I is not still incremented. So when I say next, two things happen. I becomes equal to, now if I see I is equal to 2, 2 is less than or equal to 3. So that's the reason we enter the for loop again. And then after when we say next, and if you do print sum is equal to 3 because we have added 2 above 2 to sum. So again we go to next. Okay, when we go next, so print I, so I is equal to 3. And now when we say next, 3 will be added to the sum. And if you see sum is equal to 6. And now if you see the value of I, it is 3. But if you say next, you come out of the loop because on line number 10, I is equal to I plus 1, it gets incremented to 4. And 4, we check whether 4 is less than or equal to 3. And it's not the case, so we come out of the loop. So this is how the for loop works. Okay. So now, since you understood how for loop works, we will try to do more interesting stuff using for loop. The first thing that we are going to do now is work with arrays. See why that's true, Anusha. I is equal to I plus 1 followed by I less than or equal to. I want you to again, if you want to think about it in a different way, so the equivalent code for the for loop, those of you who are a bit confused, is I is equal to 1 while I less than or equal to n, sum is equal to sum plus I is equal to I plus 1. So the loop that you are seeing from line 15 to line 19 is same as the loop that you are seeing from line 10 to line 13. Are you fine with this, Anusha? So does it make sense? Are you all with me here that why the for statement and while are equivalent to each other? So both are the same, exactly the same. So Rohan, you asked a question. I want you to trace the program execution after this class and and see it will make sense for you. Okay, it's not very difficult. But I hope you understand this semantics. All right. So now let's go to array. So this is the problem. So include, let's say you want to work with, there is a class of 100 students and we want to find the average marks of all the 100 students. How do we go about it? Do we declare 100 variables? You want to find the average marks of 100 students in a class. So if you want to store the marks of 100 students, can we have 100 variables like this? What will happen? Does this work? Does this logic work? Complex. It is complex, let's say. But what happens? How do you compute the average of 100 students? You keep writing S1 plus, if you want to compute the sum of their marks, S1 plus S2 plus S3 plus S4, you keep on typing. You cannot even iterate over them. Perfect, super answer. Who gave that answer? Let's see. Yeah, once gave a fantastic answer. You cannot even iterate over them. It's not, one is it's tedious, but it's writing a program itself. You cannot write a for loop which goes through S1, S2, S3, S4, so on and so forth. It's not going to work. You cannot write a for loop which iterates over all these variables. Okay, wait. So there is an interesting thing. So let me, after we look at this whole traversing, Survi used a nice word, traversing. Survi Sai Kiran. Good. So instead, we have this thing. So marks 100. What it means is we are declaring an array of 100 elements. We are declaring an array of 100 elements. And in order to make the code more modular, I will do number of students is equal to 10. And then I use the macro here. So now I have an array. What is the size of the array? The size of the array is 10. So there is this nice question, what if you don't know the number of students? So we'll answer that question later. It's an interesting question. So we have 10 students now, and the memory. So what happens is each element of this array, it's an integer. So this is your RAM. So it starts, so first element, second element, third element, so on and so forth. Interestingly, in C, we don't start with first element, we start with 0th element. So this is marks 0, this is marks 1, so on and so forth. This is marks 9. So we have an array of 10 elements, and those elements are allocated memory in the RAM. What is the size of this array? Total memory occupied by this array? What is the total memory occupied? 40 bytes, because each element is an integer. Integers are allocated 4 bytes. So overall memory occupied is 40 bytes. Nice. Second, let's say if the base address of marks 0 element, that is a 0th element, is 10, that is bytes 10, 11, 12, 13 are allocated to the 0th element of the marks array, then what will be the address of the first element of the marks array? What will be the 14? Okay, and what will be the 14, 15, 16, 17 are allocated to the first element, and what will be the address of marks 2? 18. Great, that's all. Awesome. So now what we want to do is we want to read the marks. We want to write code to read the marks. So what we do is for int I is equal to 0, I less than number of students. Remember, I am using not less than or equal to. I am just using less than. So int I is equal to 0, I less than number of students plus I, and then we say scanf %d. Ampersand marks. So we are reading the marks of all the students using this loop. Does this loop make sense? Okay. So now, no, it is simple. Now for I is equal to 0, we keep going through this loop. How many times we go through this loop? We go through this loop 10 times. So in the first iteration of the loop or 0th iteration of the loop, what is the value of I? 0. So when I is equal to 0, you read whatever the value that we give into the keyboard, we read into marks of 0. In the first iteration, that is after the 0th iteration, in the first iteration, we read the input into marks 1 memory location. In the second iteration, we read the data into marks 2 memory location, so on and so forth. And that's all we are doing in this for loop. Does this make sense? You're all good here? It is not running 11 times now. So once I becomes 10, what will, when I is equal to 10, will this run? Oh, okay, this is, yeah, so it doesn't run, right? So when I is equal to 10, 10 is not less than 10. The condition will be false, so it will not run. So you only run it for 10 times, not 11 times. So what is happening here? So let's draw the picture again. So you come here, this is I is equal to 0. This is the loop. You check if I is less than 10. There are two possible answers, yes and no. If no, then we do something else. We come out of the loop. No, we come out of the loop. If it is yes, what are we doing? We are doing a reading. And we are reading into the ith element. Okay. And then as we are going back, as we are plus I is nothing but increment I is equal to I plus 1. It's a shorthand for writing it, plus I minus. Sorry. And then again you come back. So initially, if you see, if you look at this loop, so initially when I is equal to 0, this condition turns out to be true. You come here, when you do a scanf, you read it into marks of I. So when I is equal to 0, the scanf, no, you update the memory location associated with marks of 0. And then you go back, you take this path, you increment I is equal to I plus 1, it becomes 1. You come back here, you check if 1 is less than 10. Again, if the condition is true, so what you will do is you go and read marks of 1. You keep on doing it when till I is equal to 9. You read it into marks of 9. So after you read the data into marks 9, I gets incremented to 10 and you compare 10 against 10 and the condition is false, you come out of this loop. Okay, you come out of this loop when I is equal to 10. This is for the time being, just assume this is the convention that is followed, that in we start with 0. Okay, we start with 0. That is the convention that we follow. Are you all with me here again? So, hey, plus I plus plus, don't worry about it. Just write I is equal to I plus 1. Let's say if marks of 0 address is no. So marks of 0, if the address of marks of 0, if it is if it is 10, then that means bytes 10, 11, 12, 13, 4 bytes are occupied by marks of 0. Are you with me here, Pranjali? And then so marks of 1, it is occupied by 14, 15, 16, 17. That's all. Memory is not available in this stretch, then it will get a complaint. Your program doesn't compile. 18, 19, 20, 21. So this is how it goes. Not 4 bits, 4 bytes, guys. Why is the address starting from byte 10? Because I said so. I just took an example, Harshit. Okay. Why can't it be placed random? Why only continuous? This will be helpful. If it's not continuous, we'll have lots of troubles actually. 4 bytes because integer is 4 bytes. Okay, we should move on. What troubles? Arrays have to be, if they are not continuous, you will see the problems at a later stage. For the time being, so this is what it is. Array is allocated memory in a contiguous fashion. Okay? Are you all with me till this point? So Vansh is there to help me. The trouble will be to find the memory address of every element. Thank you, Vansh. Okay. So now we want to compute the sum of all the marks. How do we compute the sum of all the marks? See, I am just copying this code, the for loop code here and pasting it. Format document. One thing that I introduced here is we declared variable I as a part of this for loop. So we say that the scope of the variable I is within this for loop. You cannot use the variable I before this, outside this for loop. So this idea of scope, the scope of variable I, the scope of variable I is within for loop. We can use only within for loop because we declared it here. So on line 15, because of that, you can see that there is an issue that it is complaining I is not defined. Okay, so we have to define I again here. And this I and the I in the first for loop and the I in the second for loop, they are different. This I scope is within this for loop, and the second I, it's a different avatar, and its a scope is within the next for loop. Okay. And so other thing is number of students. And we would like to use a variable sum. And how should I fix this code? What all the things I need to do to fix this code? Like loop 15, the for loop on line 15, is it good? Can we change the for loop? So I will, since we are going from 0 to 9, so we should have I is equal to 0 and we should have I less than number of students. Now is line number 15 okay? Is line 15 okay with this change? I is equal to 0, so we are going from 0 to 9. And how should we fix line number 17? Yeah, we don't want to add I, we want to add the data that is present in the ith array element. So we do marks I. That is a different program apart. So in this code, we are not indexing arrays, we are adding the sum of first n numbers. So I should go from 1 to n. I can start anyway, that's not the problem. But as per the in this program, I should go from 1 to n. And in this program, I should go from 0 to number of students minus 1. Okay, so that's the reason why we have to change things like this. And then, so printf average marks is equal to %f sum divided by number of students. So do you see any problem in this? So do you see any problem? So here the problem is, sum is an integer and the number of students are also integers. So let's compile a program and see what happens. Okay, it will say GCC array.c. Now you can see that the value that is generated on line number 20 is an integer, but we are using %f. So we are getting a warning. It's not an error, but we are getting a warning that, hey, you are trying to use a %f format specifier for an integer value. So let's say we use %d and see what happens. And now it compiles. But then I have a problem. I don't want to give 10 inputs. So I just want to use 5. Now, since we are using a macro, I don't need to change. We are using number of students in 4 different places. But I did just change on line number 3 and everything automatically works out. Does it make sense? Yes, no? Okay. So now let's compile a program. So GCC array.c. What we are saying is, I'm just saying earlier number of students is 10. We just made it 5 and automatically everything got changed to 5. Advantage of using a macro. This is advantage of using a macro. Now let's run the program. Let's say the marks are 1, 2, 3, 4, 5. So the average marks is 3. Is it the average marks really 3 or what is the actual average? 3, yeah? Okay. Because sum of 1, 2, 3, 4, 5 is 15 and 15 by 5 is 3. So, but let's say we got lucky. That's true. So that's what happens, when you test your programs and submit, you think you give a specific input which works and you submit, it doesn't work. So let's give some, so 10, 21, 33, 67, 90. Does this work? What is the actual average? Or we got lucky now also? 44.05. Great. See, the actual average is 44.05, but 44.2. Okay. So it's 44.2, but that got truncated. Okay. So what happens is here, when you divide an integer by integer, when you divide, so this is 44. Can you tell me what do we get in the numerator? When you add all the marks, 221. No? Okay, great. So when we have 221 divided by 5, so this is an integer and this is an integer. So what happens is the value is 44.2. So this get automatically truncated. Okay, and that's what we are getting here. So if you don't want this truncation to happen, if you don't, how can we avoid this truncation to happen? There are a couple of ways of doing it. One way of doing it is by what is called as a typecasting. Okay. So when you do this float sum, what happens is, so the way your numerator, this is what is called as an implicit or explicit, sorry. This is what is called as an explicit typecasting. This is explicit typecasting. So when we do this explicit typecasting, so this expression 221.5, it gets changed, it gets transformed to 221.0 divided by 5. Okay, this is the explicit. So we moved from here to here because of the explicit typecasting. Because of the explicit typecasting. And now what happens is from here to here, the numerator is a float and the denominator is an integer. Again, we cannot divide apples with oranges or the other way around. So we promote. So we promote 5 to 5.0. This is what is called as an implicit typecasting. We are not doing it, but it is automatically happening. Implicit typecasting. Implicit is done by the compiler, Anusha. Awesome. Explicit means we do it. We do it is done by the programmer. Implicit is automatically done by the compiler. Are you all with me here? So if you think of this, this is 1. So this is happening here. Implicit is 2, and this is happening here. All right. And in this particular case, it is promotion. The variable is getting, so we are promoting an integer to a float. That's what is happening, either through explicit means or implicit means. In both these cases, what we are having is a promotion. That is, there is no loss of information. There is no loss of information. Are you all with me here that the typecasting is happening? And so there is a promotion, there is no loss of information. As against truncation, sometimes no, when we will look at it later. So now, yeah, so that's all. So let's compile this program and see what happens. So GCC array.c. Did I change it to %? Yeah. A.out, and let me copy all this. Copy. See, and the average marks is 44 point. Are you all with me on this example? Why 1 at the end? It's a good question. So we don't have exact representation of floating point numbers in computers. Some numbers you can represent them exactly, some numbers you will not be able to represent. So don't worry about it for the time being, that's all I would say. Okay, because there are infinitely many numbers and you have finite number of bits. Do you think every real number can be represented exactly? Is the code looking good? Are you all with me here on this code? What happened in the code? So now we move from 1D arrays to 2D arrays. When we go to 2D arrays, we can start working with matrices. And that will be the theme for your next assignment. Okay. So now we want to work with matrices. So we can define a 2D matrix or a 2D array as follows. Okay. So now we have a 2D matrix. Okay, pay attention, guys. You can know there are this is an important idea. So this is your 2D matrix. This is row 0, calling it as R0 is row 0. These are rows R1, R2, row 0, row 1, row 2, and then column 0, column 1, column 2. So these are columns. And these are rows. All the drawing is gone, sorry. I have to draw it again. Okay, no problem. You're all hungry? Can you 5 more minutes? So how do we access? So how do you call, if you want to access this element, what is this, the row of this element? What is the row number of first row? This is row 0, this is row 1. And what is the column? This is column 1, C0, C1, C2, R2. So this is, you access that element using A of 1, 1. Kabir, no, it's not 2, 1, 1, yeah. This is how we access this. Are you all with me here on 2D matrices, 2D arrays matrices? Any questions? Okay, all good. So now let's write code to read a matrix. Read a matrix. This is going to be fun because you will be seeing a 2D loop, and this could be useful for you in your challenge problem from first challenge problem in assignment 1. I'm doing some cut, copy, paste stuff. j is equal to j plus 1. So now here what is happening in this code, have to bear with me for 5 minutes. I know you're hungry, and after that we'll take a break. I want you to cover this idea so that you will be in good shape for tomorrow. So initially you start with I is equal to 0, and then you enter the inner loop, body of the outer for loop. This is the outer for loop, and this is the inner for loop. With I is equal to 0, you enter the inner for loop and execute it for 0, 1, and 2. So when I is equal to 0 and j is equal to 0, you read this element. Okay, so here, as you are iterating when I is equal to 0, logically what we are doing in the inner for loop, in the outer for loop I is equal to 0, and in the inner for loop, what are we doing in the using the inner for loop? We are reading the first row of the matrix. When j is equal to 0, we read this element. When j is equal to 1, we read this element. When j is equal to 2, we read this element. Are you all with me that when I is equal to 0, for different values of j's, we go through each element of the row 0 and read all elements of row 0. And similarly, when I is equal to 1, we do the same. 0, 1, 2. And in the when I is equal to 1, we are reading row 1 of the matrix. And when I is equal to 2, we are reading the row 2 of the matrix. So that is how we can read the whole matrix by writing this 2D loop. All right. Are you all with me on this one, this 2D loop? What is happening in this 2D loop? So if you think of, I is equal to 0 as going from 0 to n as different floors in a building, different floors in a, I is equal to 0 is the ground floor, I is equal to 1 is the first floor, I is equal to 2 is the third floor, I is equal to 3 is the fourth floor. And the inner J loop, inner for loop, it is like visiting all the rooms on that particular floor. For J is equal to 0, you visit the 0th room in the ground floor and you put a coin or whatever that is there in that room. And then J is equal to 1, you visit the first room in the ground floor. You keep doing that. After you are done, you come back and you go to the first floor and you repeat the process. Does this analogy make sense? This floors analogy? As I is equal to 0 to 1, so as you keep, this is an elevator. This is the elevator loop. And this is a sweep or scan loop. Sweep or at a floor, you scan everything here. Okay, so you're putting, you're not allocating rooms to visitor, you're, yeah, you can think of whatever the interpretation you want to have, you can have. But I would like to think of the outer for loop as an elevator loop, which takes us from one dimension to level 0, level 1, level 2, level 3, level 4. And the inner for loop scans all the rooms in that same floor. Elevator loop and scan loop. That's, you remember this analogy. And if you have a third loop, then what happens if you have a third loop? Then like Disney in the Wonderland or whatever, you just go to a room and you disappear into a different dimension and then have fun there. Rooms within rooms. Or if you have a third loop, then you can, let's say if you're in a dorm, in a dorm there are multiple beds within the same room. So Inception. Transcending reality. Yes. Once you write 3 for loops, you transcend reality. Okay. Are you all with me here? Oh, awesome, Abhinav. Oh, so don't floors, buildings, that's also good actually. Buildings, floors, rooms, beds. So Abhinav is my man. Very good analogy. Yeah. Yeah, all those things are possible. For the time being, let's stick to this. I have only 5 minutes. I want to complete. Elevator loop and scan loop or sweep loop. Just remember that. Okay, shall I proceed further? Yes, you're all with me? Happy? Good? Okay. So now we want to do the same, but what we want to do is now we want to visit all the rooms and print who are all there in the rooms. Print who are all there in the rooms. And we want to print nicely. So let me do one thing. So printf level %d /n I. Okay. Printf r %d is room number. With some space. And after I print everything in a room at a level, I want to kind of have a, nicely formatted. I want to go to different level and do. Okay, so now are you with me on this code? Yeah, so you go to a level and you print scan, and then so what is r %d? R is room. Okay, the loop is already there, no? So let's compile this program and see what happens. GCC 2D array.c. One, 2, 3, 4, 5, 6, 7, 8, 9. Now you can see on level 0, rooms R1, R2, R3 are there. And on level 1, R4, R5, R6 are there. On level 2, R7, R8 are there. Done? Does it make sense? So now, if you don't like all these, but now this is just for our understanding. But let's say if you want to just work with matrices and want to print these matrices nicely, I didn't put /n in line 24, that's all I did. So now, this is, you are running a.out. Our matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9, and we print pretty print. So the %6d here, it controls how much width to use to print the value. Okay, let's say if I use 3, then what happens is only 3 fields will be used. 3 spaces or 3 columns will be used for printing. So the spacing in the matrix will be less. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you see the spacing is less. Anusha is doing awesome. Very good explanation for a question which I am not going to answer now. Are you all with me here on this example? It doesn't skip 6 spaces. It uses 6 columns to print. Everything will be adjusted within 6 columns. Are you all with me here on this last example on 2D matrices? How we are reading and printing? Okay. So then we will stop today's lecture here. And this will help you in problem 5. Problem 5 is ijk, in physics a vector is 2i plus 3j plus 4k, 3 dimensions, but in computer science a vector is it can be any dimensions. Okay, how is the dot product of two vectors defined? Sigma xi yi, I is equal to 1 to n. This is the dot product of two vectors. Okay, so don't confine yourselves to 3 dimensions in vector computation. %3, it gives 3 columns. Yeah, it can be any not any number of dimensions. There is only one dimension. In physics, we call it as that ijk as there is a matrix dimension, and you just have to read the vector into an array. That's all. Then try it out, Aman. Aman has a good question. So Aman, try it and see what happens. I also don't know. If you need a 2 by 3 matrix, then you define it's very simple. It's not, you don't need to read this lecture again, watch this lecture, and we will again review these ideas in the Saturday class. Okay. Okay, we will stop here. We are running out of time. And on Saturday class, we will continue our discussion. And any doubts you have, they will be clarified in the Saturday class. So all your questions on compound statements, multiple conditions, they will be answered by Saturday. But meanwhile, you should learn to read the book. You should learn to read the book